Hello students, I am Dr. Shilpa K. Gowda, Associate Professor, Department of ECE, SJBIT. So today I am going to explain some topics related to Module 1. So first, today we will start with the diode applications. So mainly we know that all the electronic circuits need a DC power supply of adequate voltage for their operation. This DC power supply block diagram mainly consists of four stages. One is a step down transformer, next one is rectifier, next one is filter and regulator. A step-down transformer is a device that has two coil windings, primary and secondary, used to convert a high voltage AC voltage 230 volts to 550 Hz to a required low AC voltage. Rectifier is a device has one or more diodes converts secondary AC voltage to pulsating DC. Filter is a circuit used to remove fluctuations or a ripple factor present in the rectifier output. So the example of this filter is a capacitor filter, LC filter, pi filters, etc. Next we have voltage regulator. It is a circuit which provides a constant DC output voltage irrespective of changes in load current or changes in input voltage. Next we will start with the rectifier circuit. So a rectifier circuit means it is a circuit which converts an alternating AC voltage into a direct DC voltage. The different types of rectifiers are half wave rectifier, full wave rectifier, and a full wave rectifier is further classified into center tap full wave rectifier and a full wave bridge rectifier. So first we will start with the half wave rectification. So the rectifier which conducts current only during one half cycle of an AC input is called half wave rectifier. So that is the operation of this half wave rectifier is during a positive half cycle of input voltage, end A becomes positive with respect to end B. Hence the diode is forward bias and current flows through load resistance RL. During the negative half cycle of input voltage, end A becomes negative with respect to end B. Hence, the diode is reverse biased and no current flows in the circuit. Therefore, current flows through diode during positive half cycle of input AC voltage only, and it is block during the negative half cycle. And also we have rectifier efficiency. So rectifier efficiency means it is defined as the ratio of DC output power to AC input power. It is given by the equations eta equals PDC by PAC into 100. Next we have a ripple factor. It is defined as the ratio of RMS value of AC component to the RMS value of a DC component. So that is a ripple factor will be equals to VAC by VDC. Next, voltage regulation. It is the factor which tells us about the change in DC output voltage as load changes from no load to full load condition. Next, the transform utilization factor. The transform utilization factor will be equals to DC power delivered to load to the ratio of AC power rating of a transformer. So next we have here advantages of a half wave rectifier. So the advantages in half wave rectifier, only one diode is required. Half wave rectifier is a cheap, simple and easy to constructor. The disadvantages of a half-wave rectifier is a ripple factor is too high, efficiency of rectification is low, transformer utilization factor is low, AC supply delivers power only half the time and therefore the output is low. So next we will start with the full wave rectifier. So the rectifier which conducts during both positive and negative half cycle of AC input is called a full wave rectifier. So first we will consider the center tapped full wave rectifier. In this during positive half cycle diode D1 is forward bias, and diode D2 is a reverse bias. Hence, diode D1 is on and diode D2 is off. During the negative half cycle, D2 diode D2 is forward biased and diode D1 is reverse biased. Hence, D2 is on and D1 is off. Therefore, the current flows through load resistor RL for both half cycles of input AC voltage. So the advantages of a center tap a full wave rectifier, where the ripple factor is less, efficiency is high, and DC output voltage and load current are twice compared to half wave rectifier. Next, we have some disadvantages of this center tapped full wave rectifier. Here, the diodes used must have high peak inverse voltage and difficult to construct and locate the center tap on secondary windings of the transformer. And the last disadvantage is that the output voltage is half of the secondary voltage. Next, we have bridge rectifier here. So in full wave bridge rectifier, so in this operation here, during the positive half cycles, diode D1 and D2 are on and D3 and D4 are off. The current flows through the path A, B, C, D, E, F, A. And also during negative half cycle of input voltage, the diodes D3 and D4 are on and D1 and D2 are off. And also the current flows through load resistance RL and the path is F, E, C, D, B, A, F. So this is the full wave bridge rectifier. So next we have the advantages here. The advantages of full wave bridge rectifier is transformer cost is less, output is twice when compared to center tap full wave rectifier for the same secondary voltage, and also the peak inverse voltage is one half compared to center tapped full wave rectifier. Next, we have disadvantages of full wave bridge rectifier. Since it is requires 4 diodes, the use of 2 extra diodes cause an additional voltage drop, thereby reducing the output voltage. Thank you.